All right, so we almost have 30 minutes, less than 30 minutes to talk about uh, excavators. Let's get started. So let me manage my time. Okay. Um, so the term excavator could include a variety of, different equipment. If you look on the left-hand side, uh, a backhoe excavator is one of them, a crawler excavator, a drag line, a suction excavator. Let's watch a quick video that just introduces. Okay, for some reason it's not playing. Let me make sure what's going on. All right, I just fixed it and I'm back. Okay, so the video is ready. Let me go to full screen. And so we have hydraulic excavator, which looks like this. We have the compact excavator. Oops. We have the drag line excavator and suction excavator and a crawler excavator or a wheeled excavator. And we have different types of attachments that could modify the application of an excavator. So when the term excavator does not necessarily mean this guy or this guy, it is a type of equipment. Okay, so when you are talking about these machines, you should identify them. For example, this one would be a backhoe excavator. This one is a crawler. Well, for drag lines, we most of the time use the term drag line, and for suction, we just use the term suction. But it's good to know that you have to or you should use the appropriate term so that everybody will understand the same thing that you have in mind about an excavator. So yeah, today we will be talking about some of these guys. Let's get started with a hydraulic excavator, and I have a video and I hope it plays. Yes, it does. Okay, so hydraulic excavators, they could be a crawler or they could be a pneumatic tire. They come in many different specialized attachments are available for them, and obviously each one is good for a specific job, and you can attach and detach, and most of the times you have at least 3 or 4 depending on the job nature. You have them you store them somewhere on the job site, and the operator can go ahead and modify, can disengage and engage new attachments based on the need. So they are, there is a variety of these machines. They are so diverse. The reason being, uh, there are many types of attachment, and they can also come in different sizes. And so each one is good for a specialized task, and it's important to know that you have to select the one that makes the most economic sense. Okay, so although there is a variety, there is always a one best option that can get the job done for you with a lower cost. And um, this is a construction manager's skill and understanding of the equipment and the job nature to find the best attachment. Um, what the hydraulic control, the hydraulic mechanic, how it works. So it has a lot of, advantages for the machine. One is that it improves the cycle time. So the cycle time would be faster. It creates a positive control of attachments. Okay, so controlling them becomes more easily mechanically. It improves the control of the machine. It uh, also provides precise control, okay, of the machine and high overall efficiency. Okay, and of course it reduces. It makes the job more easily for the operator. So there are lots of advantages for the hydraulic power of uh, of an excavator. So here is a nice presentation of the space, let's see, the space an excavator can cover. So as you can see, it can cover both above the ground level and under the ground level, and up to a good height, which usually comes in tables based on the machine properties. And this is the area, you know, it can maneuver or it can work. And this guy, so this one is hydraulic hoe, downward arc, and this is hydraulic shovel, upward arc. So you can see the difference between downward and upward. Um, as you can see, downward arc has a lot better control in areas that are just in front of the equipment and even under the equipment. It even has access to this part, okay? While an upward arc, has less capabilities to work in underground space. So this is important to know. Remember upward arc and downward arc. And downward is specifically good for underneath areas. Um, so next step is to find the production rates uh, of an excavator. So if an excavator is working independently, it means it doesn't have to wait for other equipment, or its production is determined by its own operator, uh, not how other operators are working. Then to find the production, you should follow these steps. Number one, you should find the capacity, the hipped bucket load volume, or the capacity of the bucket. Um, and that information is most of the time given to us by manufacturer. So for each machine, there is a manufacturer data sheet, and that is given to us. Sometimes what becomes problematic is when you rent the equipment and the renter does not provide enough information about the properties of the machine. For most of the machines nowadays, thanks to the internet, you can Google it and you can find the bucket capacity fast and easy. Uh, Obviously, we would use loose cubic yard because it's not in situ or it's not compacted. You're working with loose soil, and loose cubic yard is a type of measurement we will be using. So there is a factor called a bucket fill factor. It means what percentage of the bucket could be filled. Okay, is it 100%? Is it less than that? That would depend on the type of the machine and, of course, the type of materials the machine is processing. Obviously, for soft materials and for smaller fine grades, the entire bucket can be filled and even heaped. But for rocks, for tough materials, um, there will be a lot of space between the the rocks, so not the entire bucket volume would be used. Okay, so there is a bucket fill factor to reflect that um, you know that changes. So um, step 3 is to estimate a peak cycle time, which is a function of a few things. What is the machine type? What are the job conditions? What is the angle of swing? What is the depth or height of the cut? For example, if you go too high, or if you go too low, it would be more difficult to cut. Okay, so the capacity, I mean, the production of the machine will changes. And for that, we just estimate a peak cycle time. Um, yeah, and if you're working with a loader, you should also consider the travel distance. So apply a work time efficiency factor. We have done this before. You're familiar with that. For example, we would say 50 minutes an hour or 55 minutes or 45 minutes per hour. It always reduces from the production when you multiply it because it's a fraction that is smaller than 1. Step 5, conform the production units to the desired volume or weight units. Okay, so sometimes you have to make some changes. You have to change, for example, loose cubic yard to bank cubic yard. So first you do the entire thing, and at the end you can easily change your number to whatever type of measurement that is needed. And then calculate the production rate. So we will do this in problems. This is the basic production formula. Okay, the production of an excavator. So what are these parameters? Q is the heaped bucket capacity. Okay, so in loose cubic yard, how many loose cubic yards the bucket can hold when it is heaped. So F is the bucket fill factor, which should be given to us. ASD is angle of swing and depth or height of the cut correction. So you multiply it by a number to consider the impact of angle of swing of the bucket and the depth of the depth or height of the cut. And T is the cycle time in seconds. It means one loop of operation, how many seconds it takes, and then you will need to multiply it by the efficiency, which is given in minute per hour, and then you need to convert it to volume correction. If you want to, you can convert it to bank cubic yard, or you can convert loose volume to tons if you multiply it by that number. Okay, so we will do a problem later. Uh, there is, let me put myself here. Yeah, this production analysis is process is shown sorry, here on my this site. Yeah, so yeah, as you can see, cycle per hour depends on cycle time and efficiency. Cycle time will depend on the load, on the load time, dump time, haul time, and return time. The haul and return itself depend on the traction, grade resistance, and rolling resistance. Then these four will identify our rim pull and drawbar. And those two will identify our speed, and speed identifies the time. Okay, so on the other hand, loading and dumping time are fixed times. So if you have the load and dump times and then you combine them with the haul and return time, what you will find is the cycle time. If you combine the cycle time with the efficiency, then you can find cycle per hour. Okay. So this will give you cycle per hour, but for production, there is another piece that is required, which is the amount of materials that could be carried. Well, it depends on the type of measurement. If you're doing it in loose, weight, or band cubic yard, there is a fill factor you have to use, and there is a capacity. Okay, so I mean the fill factor identifies the capacity. So the capacity could come in volume or weight, and from there you can find the payload, and then from there you can find the material carried. So material carried multiplied by cycle per hour would give you the production per hour, which is the material that can be carried in every hour, in each hour. Okay, so this, especially the right part of the graph is very interesting because it actually reviews some of the things we already have learned, and it explains the connection between them. For example, you will see why we're caring about rim pull and drawbar, because having those two will help us finding the speed. Okay, and once you have the speed, you can find the time. Okay, and the rim pull and drawbar are found based on the rolling resistance and the grade resistance and the traction. If you remember from chapter 6, I think. Yes, chapter 6. So try to learn this graph. It will be wonderful if you can draw it for yourself. There might be questions from it. So let me check my time here. So it's been 36 minutes. Yes, I can teach this slide as well. So hydraulic excavator accidents. Hydraulic excavators are hazardous machines because they're huge, they're super big, and they can, cover a wide area because they can rotate 360 degrees. Okay, so huge, lots of blind spots, and a lot of movement altogether means a high risk machine or equipment. So there are some some safety tips we have to take into consideration. But before that, let's learn about common causes of injury for an excavator, for a hydraulic excavator. So many of them happen because of getting stuck by the moving machine, swinging booms, or other machine compartments. Yeah, and you can imagine how horrible it is getting stuck by a bucket of a scraper. So sorry, an excavator. So being struck by quick disconnect excavator buckets when they unexpectedly detach from the stick. Okay, so in detaching them, a lot of care should be taken. Also in attaching them to make sure that they are firm enough. There is no risk of falling, especially when you're working with heavy cuts. So it means very tough type of soil in which a lot of energy is exerted into the joints between the bucket and the stick. So rollovers, yes, they do roll over. Although they are super big, they do roll over because they're not working on a very smooth or on a very level surface. Many times they are working on very steep slips, and one side is higher than the other. So the excavator operator should have a good understanding about balancing the machine's load, because when the machine is in a diagonal situation, if you apply uh, a lot of extra load on the heavier side, then there is a good chance of rollover. Okay, there's also a chance of electrocutions because the bucket sometimes could hit the power lines, um, or the machines can slide into trenches after cave-ins. Yes, so if the trenches are not firm enough, um, even if the machine is not on the trench, even if it is next to the trench, sometimes the trench can fall and the machine will become, will can even roll over if the trench is deep enough. So what should we do to prevent these things? Number one, operator must keep machine attachments at a safe distance from workers at all times. So as you can imagine, working with an excavator is particularly more hazardous in a congested work site, okay? That's why when you have the excavator, you should make sure that you don't have a lot of workers around. So it is a wrong decision by a construction manager to let the trade people continue their job in the vicinity of an excavator. Well, if you go to the fields, which most of you have, this is happening many times, but it's not a safe thing. So control work area boundaries with warning lines, railing, or restrictive signage. Yeah. So everybody should be informed. Not only the project people, even the outsiders, they should be informed that here there is excavation work in process, so in progress. So workers must be trained regarding safe practices when working in close proximity to heavy equipment. Yes, for sure. Um, I mean, the being careful should be from both sides, okay? Both the operator and the workers should be careful, should be watching one another at all times. Supervisors should consider alternative working methods to eliminate the need to place workers in close proximity, right? So that's what I was talking about. Try to shift your workers, ask them to do something else which is far enough from the excavator, maneuver area. Uh, because you never know. Um, Many accidents, I mean, most of the accidents, when you ask people, they initially thought it's totally safe for them because they are watching, the operator is skillful, and so on. But even, I mean, what can go wrong will go wrong based on Morpheus law. So you never know when, how, one thing will lead to another to distract one of the sides and then create the tragedy. So the best or the safest option is just to, um, you know, put people far from where an excavator is working. So uh, I would stop here so you will have a few minutes to work on the quiz questions. And next time we'll be talking about shovels. Uh, I hope you enjoyed today's class. I see you all next time.